An interesting thing about primes is we can prove fairly easily that there have to be an infinite number of them. Now, to move in the direction of that proof, let's just start out with this statement. Okay, if 2 times 3 times 5 plus 1 isn't prime, then there's got to be a prime that's bigger than 5. Now, how can we possibly conclude that? Of course, we know there's a prime bigger than 5. There's 7. There are lots of primes bigger than 5. We know lots of prime numbers. But we're proving that if this isn't prime, then that fact proves that there has to be a prime bigger than 5, and we never have to even tell you what the prime is. We just know that there's got to be one. And this is going to become important when we do our ultimate argument here. So, let's see. 2 times 3 times 5 plus 1 isn't prime. If it isn't prime, then some prime number has to divide it, right? Now, some prime number divides 2 times 3 times 5 plus 1. Now, I'm going to tell you that prime isn't 2. Why not? Well, if you divide 2 times 3 times 5 plus 1 by 2, that's the same as 2 times 3 times 5 divided by 2 and 1 divided by 2. Now, 2 times 3 times 5 over 2 is just 3 times 5, and we still have plus 1/2, don't we? Which means that when we divide this number, whatever it is, by 2, and of course we could multiply it out and see that it's 30, wait a minute, yeah, 31. See, I don't even care what the number is, it's the process that's important here. It doesn't look too good, but this 3 times 5 is a whole number plus 1/2. It doesn't go in evenly. We have 1/2 left over. There's a remainder when we divide it. Okay? Now that prime isn't 3. 2 times 3 times 5 plus 1 divided by 3 is 2 times 3 times 5 over 3 plus 1/3, which is 2 times 5 plus 1/3. We get 1/3 left over if we divide this thing by 3. And I'm not going to belabor it. You should be able to repeat the argument for the 5. It's not 5 either. Same type of argument. Incidentally, the main reason I don't like to talk about canceling is a lot of people try to cancel this 3 with this 3, forgetting that you can't cancel. There's no such thing. You can factor things out of the numerator and factor the same thing out of the denominator and divide them, but there's no such thing as cancellation. And then if you know that and use it carefully, you actually can do cancellation without making serious errors and causing great confusion. Now, in the next clip, and you might think about how we're going to do this, going to make the argument that if 2 times 3 times 5 times 7 times 11 times 13 times 17 times 19 plus 1 isn't prime, then there's a prime bigger than 19. Okay, we're going to extend this argument. However, I guess I haven't finished this one. Our conclusion here is there's no prime. We've tried all the primes less than 5. Have been tried. None works. So the prime we're talking about the prime we need is greater than 5, and that's what we were trying to prove. We were trying to prove that if this isn't prime, then there's got to be a prime bigger than 5. And of course, if it is prime, then this number is bigger than 5, and we still have the conclusion that there's got to be a prime bigger than 5. So the fact that this isn't, or the fact that 2, 3, and 5 are the three smallest prime numbers ensures that there's got to be a prime bigger than 5. And that argument, again, is going to extend to this situation.